a very important topic from coordination compounds. It's very important video for students who are preparing for JEE and NEET. You all know about splitting. So it's from coordination compounds. You all know about splitting. Splitting is a term that came from crystal field theory. I think you all are aware about this. But there is a problem. Problem comes when you move from octahedral geometry to square planar geometry. And when you have to talk about the energy splitting, like energy diagram of d orbitals, how you can show the energy diagram of d orbitals moving from octahedral geometry to square planar geometry? It's very simple, guys. It's very simple. Believe me, after watching this video, you will never have that problem. So you all know about octahedral geometry. So octahedral geometry looks like we have 6 ligands. So it will be ML6 like this. So there will be 6 ligands, and 6 ligands are arranged like this, that bond angle will be 90 degree. These all 4 ligands will be in one plane, single plane. So this is octahedral geometry. I am representing by OH. If I talks about the energy diagram for octahedral geometry, from crystal field theory, you know that for octahedral geometry the energy will be like dxy, here will be dyz, and here will be dzx. On the top we have dx square minus y square and dz square, and the gap will be del naught. Gap will be del naught. You all know about this. So these 3 are called T2G and these 2 are called EG. It's very simple. It's very simple geometry. So when you are moving from octahedral geometry to square planar geometry, so look how we are moving. So what I am doing, I am removing this one ligand. I can remove this one, any of the ligand. I am removing this ligand. So when I am removing this ligand, what is happening to this energy diagram? What is happening? Look very carefully. So when I am removing this ligands, you know that metal have d orbitals. So there will be dxy, dyz, dzx, dx square minus y square, and dz square. So there will be x d orbitals, y d orbitals, and z d orbitals. So those d orbitals which are facing these ligands directly are in z axis. Means what I can say, here will be dz square. So dz square looks like this. So dz square, so these ligands are directly facing dz square and other dz orbitals also. So when they are facing dz square and other dz orbitals, so when I am removing this ligand, what is happening? What is happening to the d orbitals? So there might be a repulsion between the ligand and the metal d orbitals. So when I am removing this, what I am doing, I am removing the repulsion. It means the d orbitals will be free. So there will be no more such repulsion from the ligands, and when there will be no more repulsion in z direction, z axis, what it can do to the splitting? Look very carefully. So suppose when I am removing this one ligand, I have removed this one, either one you can use. So this will be trigonal bipyramidal TBP. So the TBP geometry. And when I am doing this, what is happening to the energy diagram? So here will be dyz, dzx, dxy, and then dx square minus y square and dz square. It will be like this. Z, in the z direction you can see, in the z axis you can see the energy becomes less, means dz square is more kind of free, so it means it have less energy as compared to xy. When I am moving further, suppose I remove this ligand also, so it means the ligands which are directly facing the d orbitals of the metal, I have removed all the ligands. So when I have removed all the ligands, I came to square planar geometry. So in square planar geometry, so these four ligands will be in the one single plane. So it will be like this. Like suppose I have a book, so it will be like this: one ligand, second ligand, third ligand, and fourth ligand. So here it will be metal, and this is a kind of square planar geometry. You can try with the book that you have. So we move towards the square planar geometry. So when moving towards the square planar geometry, it means I have removed another ligand. What will happen to the energy diagram? Look very carefully. This is very important. So when I removed one more ligand, so here will be dyz, dzx. So this will be dz square. Here will be dxy, and then dx square minus y square. What happened? Oh my God! The z orbitals came. The dz square orbitals came below, and because of this, because of the energy, so their energy decreased. So it means they are free, very free, and they have very less energy as compared to dxy and dx square minus y square. So it's very interesting. We moved from octahedral geometry to square planar geometry in a very interesting and in a very interesting way. So now you can see, when coming to the square planar geometry, when coming towards the square planar geometry, we have dyz and dzx at the lowest. These are lowest energy orbitals. So when the electron will come, the electron will start filling from here. Then it will go above. So it's very interesting geometry. So coming from octahedral to square planar, now you have understood how the splitting diagram or the energy diagram of d orbitals is changing when we are moving from octahedral to square planar geometry. So it's very important. So in octahedral geometry, we have lowest d